All right, so first of all, I just want you to notice your notes might look different than this. So go ahead and just take a moment, pause this video, cross off what's in your notes, and copy these problems down into your notes. Okay, if you need more time on that, you could have paused. All right, let's take a look at some of this stuff. We have some rules that we need to be familiar with. I want to show you how these things work. So the first thing is multiplying with common exponents. And the same thing is true with dividing, because multiplying and dividing are in the same kind of field of mathematics here. So if I have two things that are being multiplied, but the exponents are the same, I could write it like this. I could write it as ax times y, put in parentheses, and they both have that same exponent. I can also go backwards, right? So if I have something in parentheses, they're being multiplied, they're to that exponent, I could separate them and apply that exponent to each term. Same thing is true with division. I could put them together as one fraction and put that exponent out there. That's the reason why, by the way, we can rewrite an exponent, or sorry, a radical, like say like this. We could rewrite it like this. That's why. Because a radical is just like an exponent. And so essentially what we're saying is, hey, I could take it from being with to both and apply it separately. We'll do some examples of this. Actually, let's just go ahead and do an example right here. So like, let's say I had, well, really it would just be something like 5x squared. What you could do is you could think of that as like 5 squared times x squared. And so that would simplify as 25x squared. See, this square is applied to everything. Now this square is only applied to the x. All right, here's another one, multiplying with common bases. So here's the rule. If they have the same base and you're multiplying, all you gotta do is add the exponents. If you have the same base and you're dividing, you subtract the exponents. And this actually makes a lot of sense if you think about it. So let's draw out an example there. Let's say I had x cubed times x squared. What does this mean really? Well, this really means x times x times x times x times x times x. Well, that's a total of 5 x's, so we can say x to the 5th. Well, the shortcut there is just add these exponents. 2 plus 3 is 5, okay? And dividing is the same way, all right? So let's see, for the rule for dividing, it's the same thing. So like, let's say I had x to the, oops, let me write it again. X to the 3 over x squared. Well, really that means x times x times x over x. And these would cancel out, and you're left with just an x. Well, the shortcut, again, is that you would just say, well, this is just x to the 3 minus 2, which is x to the 1, which is what we already have. Okay, so that's why that works. So when you're multiplying, you add the exponents. When you're dividing, you subtract. Again, only if the bases are exactly the same. And lastly, whenever you have an exponent to an exponent, you just multiply. Okay, so this is like, let's say I had like x squared and then 4th. This would be x to the 2 times 4 or x to the 8. That's what that would be. So that's how that one works out. Another way you might see something like that is like, let's say I had more than one variable. Let's say I had like 5t. Well, what you could do is you could rewrite this as x to the 5th to the t, and then maybe you could plug in an x and you could figure something out a little bit. So that's kind of how that works. Okay, so again, let's go to these problems. Let's apply this now. In all of these problems, they want us to rewrite it like this, k times x to the n, meaning they just want some value out front. It could be a fraction, a value, times our variable with a single exponent. The exponent also could be a fraction. So let's see what we got. Well, oh, sorry. Zoom in here. The first thing I notice is that this is in radical form and this is in exponent form. So let's get it all in exponent form. So that'd be 2. Remember, if there's not a number in the crack, it's an implied 2. If there's not an exponent, it's an implied 1. So this is really like saying 2x to the 1/2 times 3x to the negative 3/2. All right, these are easy. We're going to multiply those together and get 6. But what do we do about these? Well, we're multiplying here, and they do have a common base. So we're just going to add these exponents. Even though this is a negative, we just add it. So adding a negative is like, it's just like subtracting. So you have x to the 1/2 plus negative 3/2. Well, what is that? Well, I would get 6x 1 half minus 3 halves is negative 2 halves, which is really negative 1. So I'm going to write 6x to the negative 1, and boom, I got a problem here. Okay, and that is now in that format where like the k is my 6 and the n is negative 1. Again, these can be fractions. So I want you guys to try practice one on your own now. A little bit going on here. Give it a shot. It's okay if you totally get it wrong. I'll explain it afterwards, but go ahead, pause the video and give it a shot. All right, there's a lot we can do here. I'm going to choose to first rewrite it as an exponent. So I know there's a 2 in the crack. There's a 1 here. That's just implied when you don't see anything there. And then I'm going to try to simplify what's on the inside first. And I know that if I have the same base I'm dividing, I could just subtract. So I'm going to do 1 minus 1 half. 1 take away a half is 1 half. So now I have a half on the inside and a half on the outside. Well, we said that in that case, you're multiplying. So I just did 1 half times 1 half, which is 1/4. And so there's my answer. It should be z to the 1/4. All right, let's do another one. Ooh, look at this. All kinds of crazy stuff. So what's going on here is I have basically two things here. I have this whole thing to the 1/3 as well as this all to the 1/3. So a couple things I might want to do. I might want to first just try to rewrite this. Let's keep things in the parentheses for now. And I'm going to write this as y to the 5/3. Now remember, the number out here goes on top, the number in the crack goes on the bottom. So now what I have is that they're both being raised to the 1/3. What I might want to do is I want to write these both separated. And write it like this: 8 to the 1/3 times y to the 5/3. Still put that in parentheses because I have to do an exponent on that thing twice. Okay, the reason why I'm doing that again, remember, I'm trying to get to this format, k times x to the n. So I want just a single value here, x to the n. I don't want the n being applied to the k. So let's go back. So I need to think about what 8 to the 1/3 is. So let's go over here just to kind of remind you that that's like saying the third root of 8. And if I break down 8, that's like 2 times 2 times 2. And so I have a group of 3 2s, and so I can pull it out. So that's actually really just a 2. All right, then right now I have an exponent to an exponent. So what we do there is we multiply. So that's going to be y to the 5/3 times 1/3. And when you're multiplying fractions, it's super easy. You just multiply straight across. 5 times 1 is 5. So 2 to the y to the 5 over 3 times 3 is 9. Boom. And now I've written it in that format. K, my variable, to the n. Beautiful. All right, so we got one more here for you to try on your own. Very similar problem, though. I think you can handle it. Go ahead. Use example 1 as an example for this one and see if you can figure this one out on your own. And then unpause the video when you're ready to check your work. All right, so the first thing I did is just rewrite this radical as an exponent because we want everything in the same format. Then I went ahead and applied the 1/2 to both of these. So here's 4 to the 1/2 and here's x to the 3/4 of the 1/2. And 4 to the 1/2, in case you didn't know, that's just like saying the square root of 4. And hopefully you know the square root of 4 is 2, or you could think of that as 2 times 2, and therefore we have groups of 2. Okay, or groups of 2 2s. So that's a 2. For here, I just do 3 times 1 to get 3, 4 times 2 to get 8, and boom, that's it. All right, there's some good example ones for you on this one. I'll check back with you guys on the next video.